Hello students, welcome back to your favorite YouTube channel, Tomachang Tutorial. Myself Kisan Kulung, and today we are here to discuss about Avogadro's law. A very famous Italian scientist named Amedeo Avogadro found the relation between number of molecules and volume of gas and established his hypothesis, Avogadro's hypothesis. Okay, the law was previously called Avogadro's hypothesis because during the time of Avogadro, there was no experimental evidence about molecules and atoms. But later on, when molecules and atoms were experimentally verified, then this hypothesis came to be known as Avogadro's law. Now let us quickly read out the statement and try to understand the concept of Avogadro's law. Avogadro's law. At the same temperature and pressure, equal volume of any gas contain equal number of molecules. The law is very simple. Let's begin. Suppose, let us consider 3 cylinders containing equal volume of gases. Okay, these are the 3 cylinders, and all of these 3 cylinders contain equal volume of gases. Suppose this cylinder contains oxygen, this cylinder contains hydrogen, and this cylinder contains nitrogen. I am just writing for example. You can say this cylinder contains methane, this cylinder contains helium, or this cylinder contains argon, or whatever be the gas. So sulfur dioxide, carbon dioxide, whatever be the gas. Just I am taking example oxygen, hydrogen, and nitrogen. Okay. These are the 3 cylinders, and these 3 cylinders contain different gases, but the volume of all the cylinders are equal. The volume of first cylinder is 10 liter, the volume of second cylinder is 10 liter, and the volume of third cylinder is also 10 liter. Okay. Now, let us assume the temperature and pressure of the first cylinder is STP. STP means what? Standard temperature and pressure. Standard temperature and pressure. What is standard temperature? Standard temperature is 273 Kelvin, or you can also say 0 degrees Celsius. Let me write here, or 0 degree Celsius. Okay. Standard temperature is 273 Kelvin or 0 degrees Celsius, and standard pressure is 760 mm of Hg, 760 millimeter of mercury column. Okay, or you can also say 1 atmospheric temperature. The temperature of the first cylinder is 273 Kelvin, and the pressure of the first cylinder is 760 mm. And this cylinder is also is at STP, and this cylinder is also at STP. Means the temperature are equal, 273 Kelvin, 273 Kelvin, 273 Kelvin, and pressure of all the cylinders are also equal, 760 millimeter of mercury column, 760 millimeter of mercury column, and 760 millimeter of mercury column. Though the gases are different, volume and temperature pressure are equal. Now, according to Avogadro's law, if the volume of gases are equal and temperature and pressure are equal, then all of these gases contain equal number of molecules. Okay, let me write. If this gas, for example, just for example, I am writing, if this gas contain 2 molecules, then this gas will also contain 2 molecules, and then this gas will also contains 2 molecules, since their volume are equal and their temperature and pressure are equal. If their volume are not equal, then the number of molecules will also be not equal. Keep this in mind. If this gas contain, let us say, if the number of molecules of oxygen is N, for example, if the number of molecules of oxygen is N, then the number of molecules of hydrogen will also be N, and the number of molecules of nitrogen will also be N. Equal volume of any gas contain equal number of molecules. This is what Avogadro's law tells us. I hope you got this. Now, we will further move on to the applications of Avogadro's law. Let me write the applications of Avogadro's law. Applications of Avogadro's law. Applications of Avogadro's law. Number one, molar volume of any gas is 22.4 liters. Okay, molar volume of any gas is 22.4 liters, which means 1 mole of any gas occupies the space 22.4 liter. Let us say nitrogen, hydrogen, carbon dioxide. Okay, this 1 mole of nitrogen, 1 mole of nitrogen, 1 mole of hydrogen, and 1 mole of carbon dioxide. 1 mole of nitrogen, 1 mole of hydrogen, and 1 mole of carbon dioxide. All of these will occupy this much volume. This 1 mole of nitrogen has 22.4 liters volume. This 1 mole of hydrogen occupies 22.4 liters volume, and this 1 mole of carbon dioxide will also occupy 22.4 liters volume. Okay, molar volume of any gas is 22.4 liters. This is the application of Avogadro law, number one. And the second one, let me write molecular mass of any gas is twice its vapor density. Means molecular mass. If I write M, if I represent molecular mass by M, or if I denote molecular mass by M, molecular mass will be equal to 2 into vapor density. This was deduced from Avogadro's law. Molecular mass of any gas is twice its vapor density. We will prove this. Okay, to prove molecular mass is equal to twice into vapor density, molecular mass of a gas is twice into vapor density. To prove this relation, first we need to understand what vapor density is. Okay, first let us understand what vapor density is, and then we will proceed to prove this equation. Okay, let us read this out. At same temperature and pressure, the volume of definite mass of a gas is how much times heavier than equal volume of hydrogen. The ratio number is called the vapor density or relative vapor density of the gas. Okay, to understand this, let me give you an example. There are two students, student A and student B. Okay, student A is 40 kg. Let us assume student A is 40 kg and student B is 20 kg. Okay, so how much time student A is heavier than student B? To find that, what we usually do is mass of student A 40 kg divided by mass of student B 20 kg, and this kg and this kg gets cancelled, and this 20 2s are 40, 21s are 20, 22s are 40. That is, we got 2, and this 2 has no unit because unit has already been cancelled because this is a ratio number. Okay, 2. We can say student A is 2 times heavier than student B. The similar concept is here. Okay, the similar concept is applied here. Now, volume of, okay, let us say volume of hydrogen, this much, And we have, volume of nitrogen here. Let us say 10 liters of nitrogen, and let us say 10 liters of hydrogen. 10 liters of hydrogen. Okay, 10 liters of nitrogen divided by 10 liters of hydrogen. Equal volumes of gases, but different gases. 10 liters of nitrogen, 10 liters of hydrogen. When we divide the mass of 10 liters of nitrogen divided by 10 liters of hydrogen, we get how much this is. Nitrogen is heavier than hydrogen. That is the vapor density of nitrogen. Okay, now let me explain this properly. Vapor density, according to definition, vapor density, I am writing Vd. Vapor density means mass of V volume of a gas divided by mass of V volume of hydrogen. Got this point? Mass of V volume of gas divided by mass of V volume of hydrogen. This will be also in kg or gram. This will be also in kg and gram. When we cancel the units, this will remain a ratio. This is just a ratio number. You can say this is a ratio number. This is the vapor density of this gas. When we compare the mass of V volume of gas divided by mass of V volume of hydrogen, we get the vapor density of the gas according to definition. Okay. Now, since from Avogadro's law we know that, from Avogadro's law, let me write Avogadro's law. Avogadro's law. We have equal volume of any gas at same temperature and pressure contain equal number of molecules. If the volume of gas are equal and temperature and pressures are equal, then number of molecules of gases will also be equal. This is what Avogadro's law says us. We have already understood this. Now let's begin this. We don't have enough space down there. Please take a screenshot of this. I'm going to erase the upper part. Let me write. Then vapor density Vd equals to mass of V volume of a gas divided by mass of V volume of hydrogen. Volume of that gas and volume of hydrogen are equal. We have supposed the volume of gas be V and the volume of hydrogen also V. Then volume of gas and volume of hydrogens are equal means their number of molecules will also be equal. So we can write mass of suppose V volume of gas contain n number of molecules. Okay, so we can write mass of n molecules n molecules of gas divided by mass of n molecules of hydrogen, isn't it? Mass of n molecules of gas divided by mass of n molecules of hydrogen, because that gas also contains volume V and hydrogen also contains volume V. They have equal volume, means they will also contain equal number of molecules. So I am writing n number of molecules, n number of molecules. So we can reduce this to vapor density equals to mass of one molecule of the gas divided by mass of one molecule of hydrogen, isn't it? So vapor density equal to mass of one molecule of that gas means molecular mass. One molecule means molecular mass, isn't it? So let us assume, or let us denote its molecular mass by the letter capital M. Okay, mass of one molecule means mass of one molecule means molecular mass. So let us denote molecular mass by letter M. Mass of one molecule of the gas means molecular mass of the gas. Let us denote by M. Okay, so mass of one molecule of hydrogen means molecular mass of hydrogen. What is the molecular mass of hydrogen? We know that the molecular mass of hydrogen is 2, isn't it? Molecular mass of hydrogen is 2. Okay, so now let's write molecular mass of hydrogen is nearly equal to 2. You can say 2. Molecular mass of hydrogen is 2. So you can say, we can cross multiply this with Vd. 2 into Vd is 2 into vapor density equal to molecular mass. Therefore, molecular mass of a gas equals to 2 into vapor density. 2 into vapor density of that gas. Okay, if you know the vapor density of gas, you can find molecular mass by dividing with 2, and if you know vapor density, you can find the molecular mass of the gas by multiplying with 2, and if you know the molecular mass of the gas, you can find vapor density by dividing with 2. You can bring this 2 down here. This is the relationship between molecular mass and vapor density of the gas and the application of Avogadro's law. Thank you so much for watching this video. I hope you like the video. If you have any doubt, you can obviously ask your question in the comment section below. Stay safe, stay healthy, and thank you so much.